if we have a shape that can be split or is already split into two triangles, it requires a small amount more effort to actually solve for our unknowns. The largest part that we need to be able to do, though, is identify what is known and what will help us solve for what we need. The general rule of thumb is that if two triangles are connected, find the common side. Then we can use that to help solve for what is going to be needed. Now this does go back to what we had talked about in section 3 when we were solving triangles. The idea behind using what is calculated to find out what else we are needed. I had stated that unless absolutely necessary, you should not use anything that's calculated. In this section, we're going to have to do that because it is absolutely going to be necessary. The two definitions that we've already been working with as we had done, I just want to put them into nice special terms or an actual diagram to it. An angle of elevation, again, it is the angle that is measured from a horizontal line, then going up. So we can have an angle of elevation that looks like that. Or if we have an angle like that, again, it's measured from a horizontal, then going up. Whereas an angle of depression is measured from a horizontal line, then you measure it going in a downward fashion. So alternately, we have the angle going the other way. Again, it's measured from a horizontal going down. We're going to calculate side CD to the nearest tenth of a centimeter. So side CD is talking about this long side on the right. Well, in order to find out that, we're going to need to find out a whole bunch more things. In this case, we could find out lots of information. We could find out the angles, we could find out this side, but on this right triangle here, the lines may not be the greatest, but they still work. We only have one thing that's known. In order to find out our unknown, we're going to have to find one other thing. In this case, we do have to find this shared side. We need to find out what is that shared side in order to calculate what this x would be. In order to find out this side, we're going to have to use the left-hand triangle, or the bottom left. So in relation to our angle, in this bottom left triangle, this would be considered our opposite side, and this would be our hypotenuse, because it is across from the right angle. Notice how I'm not even really worried about this right triangle here until we do our next step. The ratio that uses our opposite and our hypotenuse is the sine ratio. So the sine of 47 equals our opposite side, which is 4.2 centimeters, divided by our hypotenuse. In this case, it's our unknown. I'll just leave it as a question mark. I could use a variable, I could use anything. I love doing strict manipulation. That is supposed to be a question mark. That helps us cancel off. So our unknown multiplied by the sine of 47 will equal 4.2. So our next bit of work is to divide by the sine of 47, which allows multiplication and division cancel off. As long as we divide on both sides, we maintain that equality. So our question mark would be 4.2 divided by the sine of 47. When that gets typed into the calculator, making sure my calculator is in degrees, and I know how to use my calculator, I get 5.7427753337. I'm going to keep that in my calculator. I'm going to actually leave that in my calculator, and I'll show you how to properly use it. I may have already done it, but it's not a bad thing to remember. So in our right triangle, this is actually still our hypotenuse, whereas our unknown side, which we're trying to calculate, is our adjacent side. The ratio that uses the adjacent and the hypotenuse is the cosine ratio. So we're going to be using the cosine of 26, which equals our adjacent side. Now I've labeled it as x divided by our hypotenuse, which is 5.7427753337. Now that decimal keeps on going. So in order to manipulate this equation, I'd have to multiply both sides by 5.7427753337. So that would cancel off. And our x would be this 5.7 multiplied by the cosine of 26. So what we need to do is we need to learn how to use our calculator properly so we don't have to type all of this into our calculator. Absolutely, you could write down all your characters. You'll get a relatively accurate answer. It shouldn't be any kind of issue. The rule of thumb is using at least 4 decimal places. If you use at least 4 decimal places, your answer should be pretty good. It's unlikely that using 4 decimal places, especially if you're rounding to the nearest 10th or even 100th, that your question or that your answer would be off. But let's use our calculators to our advantage. Let's use it so we can do it all the time. You have an answer button. In order to access your answer on this calculator, I'd have to press second and then my negative button. It accesses the answer. ANS stands for the previous answer. So as long as I still have that 5.7 in my calculator, I can do a few things. Either I can just simply say, okay, I'm going to multiply this by cosine 26, because my calculator stores this answer in it. And then as long as I just say times cosine of 26, my answer will be accurate. But if by chance you have cleared your calculator, what you can do, or not fully memory cleared, but if you just cleared the screen, if you press the second answer, it will retrieve that answer that was just on your screen. In this case, 5.7477, so on and so forth. Then if I press my multiplication by cosine of 26, I get 5.2. So 5.2, our unit is centimeters, and that will be a good answer. Instead of me having to type all of these characters in, I can use my calculator to my advantage. And I certainly encourage you to use your answer button and to make sure you know how to use your calculator properly or to your advantage. So this is a case where we had to use a calculated answer in order to find more things, because in this right triangle, there is only one thing that's known. Well, you could argue 2, but it's not going to help us find this side CD, when we don't have any other information, especially if we don't know any side lengths. Let's go with our next example. Sergio is lying on the ground midway between two trees, which are 100 meters apart. Angles of elevation to the tops of the trees are 13 degrees and 18 degrees. How much taller is one tree than the other, to the nearest tenth of a meter? So if we're on the ground, it says that Sergio is lying on the ground midway between the trees. So he is halfway in between the two trees. We have one tree here and one tree there. So a few key aspects to label right away is if we're halfway between trees that are 100 meters apart, from this tree to Sergio is 50 meters, and from Sergio to the other tree would also be 50 meters. Now I'm just going to give this tree a little bit of foliage. Go a little bit of Charlie Brown there. But we're going to measure the angle of elevations to the tops of the two trees as two different values. To the top of this one would have to be 13 degrees. To the top of this one, 18 degrees. The reason I've labeled it this way is because my smaller tree is absolutely going to be a smaller angle. So our question is, how much taller is one tree than the other? So we need to find out what is the difference in height. Well, the beautiful thing is, if we want to find out what the difference of height is, if we know what the height of one tree is, and we know what the height of the other tree is, and we subtract them, we'll find out what the difference is. So let's find out some information. I'll call this x, and that one y. In relation to the 13-degree angle, this would be the opposite side. This would be our adjacent. At the same time, they would be very similarly labeled on the other tree. Meaning, we're going to be using the tangent ratio in both cases. We're going to be using the tangent of 13 and the tangent of 18. The opposite side to the 13 is our unknown. The opposite side to the 18 is also our unknown. The adjacent sides are both 50. So our manipulation is just to multiply both sides by 50. Now we can solve these ones simultaneously. Let's see, what am I looking for? Yes. Those cancel off, those cancel off. X is going to equal a value, and y is going to equal a value. Here, I'll solve the one first. 50 multiplied by the tangent of 13. Now, because we're not going to our final answer yet, this one would for sure be something that we want to have at least to 4 decimal places. 11.5434. This one would be 50 multiplied by the tangent of 18. And we'd have 16.2460 rounded. If we want to find out how much taller one is than the other, we're going to have to take our values and subtract them from each other. We're going to have to find out that difference. coming out has 4.7 meters. And there's our rounding to the nearest tenth. How about this one? How tall is a taller building? Well, just like we've done before, if we have a 39 up to whatever floor this is, that would be the exact same over here by simple formula or simple properties of rectangles. So if we find out what this height is, we'd be able to simply take our 39 and add it to it to get more information. Now the downside is this top triangle here, which would still be making, on the bottom triangle would also be making a 90-degree angle. We only have one thing known in the top triangle, 31 degrees. We don't know any other sides, which means we're going to have to solve for the common side, the joint side, before we can do anything further. In relation to this angle, that'd be our opposite side. And this one would be our adjacent. The beautiful thing is this would still be the adjacent side in the top triangle. And the x would be the opposite side. Because of that simple fact, we're going to be using the tangent ratio again. Yes, the tangent ratio is used a lot for these types of calculations. We'll be using more of the sine and cosine laws next year, or sorry, ratios. But yes, they will be the laws as well. So our opposite side, 39. The adjacent side is A. See, I've done strict calculation or strict manipulation before. Let's go back to cross multiplication just so that we don't lose that skill. 1 times 39 is 39. And A multiplied by the tangent of 42 will be A multiplied by the tangent of 42. To get the A by itself, we would divide both sides by the tangent of 42. Allows things to cancel off. And our adjacent side would equal 39 divided by a tangent of that 42. So the adjacent side will be 43.313888808, but we are going to be able to leave that all in our calculator. At the same time, above here, we could have also left all of these in our calculator. And there's some quick calculations. But now that we have this, we're going to use it. I'm going to use my calculator to my advantage. I'm not being lazy if I'm using my calculator to my advantage while still showing all of my work. The main reason for being able to show that work is main reasons. A, so that you can actually be accountable for your work. Secondary, if you make an error, it's much easier to keep track of what your unknown or your, this is an X. It's a lot easier to keep track of what your errors are if you actually keep track of what you're doing. Okay, so in our angle, our opposite side is our unknown. I could use O, it just looks too much like a 0. Divided by the adjacent, which is 43.3, so on and so forth. Multiply both sides by the 43.3. X will be 43.3 multiplied by the tangent of 31. So when I use my calculator, I have that in my calculator. I can use the second answer, or I can just simply take it and multiply by the tangent of 31. I get 26.0 meters. To finish off our question, though, to find out how tall is a taller building, I'm going to have to take the 39 and add the 26. So 55 meters. And our last example is a fancy one, and it is the focus that allows you to actually achieve mastery of this unit. You have to use 3D modeling. So a 35-foot communications tower is due north of Park Ranger A. Park Ranger A spots a blue-footed bluebird on the top of the tower at an angle of elevation of 70 degrees. The bird sees Park Ranger B at an angle depression of 50 degrees. There's a typo in here. They are due east. I can't believe I forgot that in there. So because of this, we have a whole bunch of information. For example, we have a communications tower. We have a blue-footed bluebird. Give it a yellow beak. Maybe an eye. But what this is producing is it's actually producing a 3D modeling. It's creating a 3D picture. Because this 35-foot communications tower is due north. So I'll add my direction in here. That is our north direction. And that ranger sees it at an angle of elevation of 70 degrees. Now we can assume that the tower is actually straight up and down, which means that that's going to be a 90-degree angle. At the same time, though, this same bird sees Park Ranger B at an angle depression of 50 degrees, which means measuring from a horizontal down. So this angle is a 50-degree angle. Now I'm just going to finish off my diagram here. Absolutely maintaining this is our 90-degree angle. Same time, that is a 90-degree angle. We have Park Ranger A and Park Ranger B. We're going to have to find out how far apart are the rangers. So this is creating a 3D object. I know that when I'm starting to see this immediately, it looks like this point right here is actually coming out of the page, whereas it's actually into the page. If we need to find out what this is, we're going to have to find out some more information in it. For example, we're going to have to find out what is that, and what is that. Well, to find out our blue question mark, this would be our opposite, this would be our adjacent, which means, yeah, we're going to use the tangent ratio again. Tangent ratio, extremely useful. Opposite side, is 35. Our unknown is our question mark. I like doing my strict manipulation. So question mark multiplied by the tangent of 70 equals 35. That cancels off. And we can divide both sides by that tangent of 70. So that all cancels off. Blue question mark, therefore, is going to be 35 divided by the tangent of 70. So 35 divided by the tangent of 70. Oh, definitely wrong color. My blue question mark comes out to be 12.7390 to 4 decimal places. The reason I know that I'm going to have to do some more things. There's other ways around it, and I may be showing you that in further years. But this is as best as I can really do. It's 12.7390 feet. My green question mark, though, well, if this is the side, if we've just created a rectangle here, this would be the exact same information. At the same time, that would also be 35 degrees. There is another way. We could take the complement of our 50 and use the 40 degree. But let's just use what we have. 35 would be the opposite. This green question mark would be the adjacent, which means that we are going to use our tangent ratio again. So I'm just going to move that over slightly. Tangent of 50, opposite side, is that 35. The adjacent side, question mark, same manipulation, multiply both sides by the question. So our unknown multiplied by the tangent of 50 would equal 35. And divide both sides by the tangent of 50. Giving our question mark as 35 divided by the tangent of 50. And in other words, how far Ranger B is away from the communication tower. Comes out as 29.3685. But we need to find out this side. Well, the beautiful thing is, if Park Ranger is actually due south, because it sees the communication tower that's straight north, and the bird sees Park Ranger due east, this is also a right angle. And if we have two sides of a right angle triangle, we can use our Pythagorean theorem. And that is exactly what we're going to do. We're going to take our 12.7390 squared, add it to our 29.3685 squared to equal what our x squared is. So if I take 12.7390 squared, the beautiful thing is I can actually take all of this in my calculator, and I might as well do that. Yeah, save myself a little bit of work here. So I have my 12.7390 squared, and I add my 29.3685 squared. Get 1024 0.790913. I know that that's going to be an irrational number, which means that's going to continue on. But it also allows me to simply take the square root of that number, which really means taking it to the power of 0.5. And my x equaling 32.0, and the unit is feet. So the rangers are 32 feet apart. Now, it's up to you to have fun.